Okay, so suppose that I have a function f of x and its inverse f inverse of x, and I know that they're defined for all values of x. They're defined for all values of x, and I know that f of 1 is 2, f of 1 is 2, and I'm asked what is f of f inverse of f of f inverse of f of f inverse of 1? Question mark. And the question mark is in blue. Probably subconsciously I did that because of that show with the dog from a while back. But what I want to know is what is this? What is this monstrosity of a composition of functions? And this is a tricky problem because it seems kind of counterintuitive, right? It's so knowing that f of 1 is equal to 2. Well, this tells me that f inverse of 2 is equal to 1, right? That's what that gives me. It does not, and I should probably highlight this in something we haven't used yet, maybe like this. It does not tell me anything about what f inverse of 1 is, right? It doesn't tell me what is f inverse of 1. And so people might be thinking, wait a second, what is going on here? I was expecting, a 2 in there, and then I could have solved this, or if it was an f and then a 1, I could have solved this. But what am I going to do? They don't tell me what f inverse of 1 is. And that's the great thing about this problem, is that it actually doesn't matter. We don't need to know what f inverse of 1 is. We know what f of f inverse of 1 is. It's 1, right? Functions and their inverses undo one another. F inverse of f of x is x, and f of f inverse of x is x. I can actually go through and just cancel these f's and f inverses in pairs. I can cancel those, and I'll just erase and try to get the right number of brackets with this. I can cancel those two and say, all right, well, f of f inverse of 1 was just 1. I don't think I need the question mark anymore. And then I can cancel the next pair. F inverse, cancel again. They cancel with that, and the last thing that I have is, or the second last thing, is f of f inverse of 1, which of course, these cancel as well, and this is just 1. And I actually could have looked at the beginning and seen that I have an even number of these things, right? That these things come in pairs. I can say, oh, there is an f and an f inverse. There is another f and f inverse. And here is what color should I do? Yet another f inverse pair. And these are going to cancel. These in pairs. I can just slash those and say, okay, they all undo each other, and what do I get? Well, in the middle I have a 1 here, and so 1. It's kind of an awkward one, but 1 is the answer. And generally speaking, when you see these big, scary-looking questions, that's usually a tip-off that the answer is actually disarmingly simple. That there's some really simple little thing that you can do to get the answer almost immediately. Whenever you see a gigantic mess of stuff like that is a very strong indication that there's a little trick. There's a little thing that if you notice it, it will be really easy. You very rarely have to do monstrous computations or huge complicated stuff. That the idea is usually that if you understand what's going on, if you realize the concept of the underlying thing that's happening here, and this will continue to be the case into first year, in particular in 187. The course coordinator of 187 last year, and also the year before, there were different coordinators, but they both loved to do this and were really, really good at it. Whenever you see something which looks so complicated that your head starts to spin, it is almost certainly extremely, extremely simple if you realize one key thing, and that's exactly what they're trying to get you to realize. And this is why we focus on concepts and conceptual depth and understanding.